Hey guys, here are answers for the molarity review on page 18. And then if you need any help, I'm going to walk through each of the problems. So if there's an answer you're not sure of or you want to see the work, you can just find the question that you need. Okay, so let's go through. First thing you want to do is highlight some of the numbers that you see. And then you have to decide which formula you want. So if I make a list, this question has grams, and I see liters, and I see a molarity. So that's not exactly the same, but remembering that we can turn grams into moles, that means that the formula that we're going to use is the one that's m equals moles over liters. So that's why we're going to choose that formula. So they give me the molarity number, so that's 2.0. They give me a liter number, 8.70, so that must mean x goes here with the moles. Remember to put this over 1, then you can cross multiply easier. So x equals, if I cross multiply this way, I get, 17.4. But remember what we just solved for was moles, and the question asks us for grams. So we have to take it one step further and do 17.4 moles and do a fence to turn that into grams. Okay, so the compound that we have is CuF2. We have to find the mass of that to go with the grams. So Cu, there's one of them, and if you check your periodic table, that weighs 64 apiece. There are two Fs. They weigh 19 apiece. When you add all that up, that gives you 102. That's the mass that you'll put there. So when you do that multiplication, your calculator will tell you 1774.8, and last thing you'll do is sig figs. We started with 3 and we started with 2. We'll go low and we'll end with 2 sig figs. The second sig fig is here at this 7. The other 7 is going to make that round up, and for these two numbers, the 7 and the 4 that we chopped off, we have to put zeros back in. You do not need to replace anything on the right side of the decimal, so the 8 doesn't matter. Lastly, you were solving for grams, so that's the unit that you put on. Alright, let's take a look at this one. So highlight the numbers that you need. Grams. Then you need to make a list and figure out which formula you have. So I see something about concentration. Concentration means the same thing as molarity. Then I see a liter number, and then I see a grams number. So that's not exactly the same, but remember, grams we know how to turn into moles. So that tells us the formula that we're going to use to solve this is m equals moles over liters, and that's why we chose that formula. So they give me a liter number, so I'll put that down there, and it says what is the concentration. So that means x will be where the m is. Molarity and concentration mean the same thing. The problem is they gave me a grams number and the formula calls for moles, so we need to do a quick fence to turn our grams into moles to substitute for that formula. So we have FeCl2, so we need the mass of that. So if you grab your periodic table, Fe weighs 56. There are 2 chlorines, they weigh 35 apiece. When you add that all up, the mass that you get is 126. Whoops. That goes in your fence here. So when you do that fence, this is 0.992 moles. Now we can put that into our formula. Now we have all the pieces. When you do that division, you get 2.20444 something, and you're just going to check your sig figs. Both of the starting numbers had 3 sig figs, so we're going to end with 3 sig figs. That will be right here. Oops, I don't need that dot. So because of the 4 afterwards, the 0 is going to stay. 2.20. We were solving for concentration. The unit for that is m, or molarity. Alright, so we're going to highlight all the numbers that we need. Then we're going to make a list of what we've got. So here I see milliliters. Then there's another milliliters number. Then I have an M for molarity, and the question says that I need to calculate what will the molarity be. So if I think about the fact that both of these milliliters represent volume numbers, I need a formula with two m's and two v's in it. So the formula we're going to use to solve this is m1v1 equals m2v2. Okay? So I'm looking for the molarity, so that means that x goes for one of the m's. It doesn't matter if you make it m1 or m2. I'm going to make it m2 because it's the diluted, which means it will be the new solution. If you put it for m1, it'll come out the same. Okay. The starting molarity that I had was this 0.25, and the amount of that I had was 25 milliliters. So see how they're together in the question? Then you'll put them together into the formula. For V2, you're not going to use 125. It says you add 125 milliliters. I already had 25, so you have to do that addition to come up with V2. So when I start to simplify, I can combine like terms. I can multiply these two numbers and get, 6.25. On the other side, I get 150x. And then you can just use algebra and solve here. This cancels. X equals on my calculator 0.041666 repeating. So then we're just going to check out our sig figs. We started off with 3 and 2 and 2. So we're going to make this have two sig figs. That 0 is not significant, so the second sig fig is really here at the 1. But because of the 6, that's going to make it round up. That's going to make your answer 0.042. And we were looking for a molarity. That means M is the unit that goes on our answer. Okay, if I look at number 4, highlight the numbers that you see. We've got this, we've got this, and then we have to decide on a formula. So I see grams, it says liters, and it wants the molarity. So it's not exactly the same, but remember, grams can be turned into moles. So then I need a formula that has these three things: moles, liters, molarity. That means that I need to use M equals moles over liters. So let's put in what we know. We have a liter number, which is 0.50. Question says, what is the molarity? So X must go here. The problem is they don't give me a mole number, they give me a gram number. So that means we're going to do a quick fence and turn our grams into moles. So we have to calculate molar mass, and here is our compound. So this is a long molar mass. Grab your periodic table. So we've got Cr, there are 3 of those, and the mass of one of them is 52. For the P and the O, remember you have to distribute that 2 inside. That means there are 2 P's and 8 O's. We got that by multiplying and distributing inside of that parentheses. Mass is there. We've got 31 from the periodic table, 16. When you add all of that up, mass that you get is 346. That goes into your fence here. And so the moles that you get there, so you have 0.3890. What we just found was the moles. That's what can go on the top here. When you do that division, you get 0.778, and then you just have to check out your sig figs. We had 4 and we had 2. That means we want to go low and end up with 2 sig figs. That will be right there. The 8 is going to make that round up, so 0.78. And because, we were looking for molarity, the unit will be M, or molar. Alright, next question. So you're going to find the numbers. So the question says what volume, so I'm going to need something with volume. Then I see a molarity number. Then there's another milliliter, which is the same thing as a volume number. And then an M here. So I need a formula that has volume, molarity, volume, molarity. That means I'm going to choose M1V1 equals M2V2. Okay, so So let's put in, I know that this is a molarity number, so 2.0, and I don't know the volume of that, so I can put an X there. I have the other molarity number here, 1.25, and the volume of that solution is 750. So now we just need to use algebra to solve. You can combine the like terms and multiply over here. That gives me 937.5. Solve with algebra, divide. Calculator says x equals 468.75. Last thing we're going to check out are our sig figs. We had 3 here, 2 here, 2 here, so we're going to end with 2. That second sig fig is right here at the 6. The 8 is going to make it round up though. Now we have to put in a 0 for anything on the left of the decimal that we chopped off, which is the 8. You don't need to worry about the things on the right of the decimal. Last thing is you were solving for a volume. Volume has the option to be either milliliters or liters. You just need to look for the clue in the question. Because there were milliliters in the question, we're going to put milliliters on our answer. And that's it. Alright, let's look at this one. We're going to find all the numbers that you need. Then we have to decide on a formula to use. So it says how much water. That means we're going to be looking for a volume. Okay. Then I see milliliters, which is the same as another volume number. And then I have 2 molarity numbers. So I need a formula that has 2 volumes and 2 molarities. That means the formula will be M1V1 equals M2V2. Okay. So how much water would I need means I'm looking for one of the volume numbers, and it doesn't matter if you do V1 or V2. I'm going to make it V1. If you put it as V2, it should come out the same. This other milliliter number will be the other volume, so you can put that in. So you'll know that these two numbers are close together in the question. There's the molarity and there's the volume, so you'll put them together into the formula. I'm looking for the volume to go with that molarity. So then you just have to solve. So 1x is the same as x. My calculator says 1125. And then we're going to check out our sig figs. So we had 2, 4, 2. We're going to make that 2 sig figs. That's here. So x equals 1100. For the 2 and the 5, you have to put zeros back in because you chopped them off. Okay. Last thing is it says how much water would I need to add, right? So it's not actually asking me for this 1100. I actually want to know what's the difference between that and what I originally had. When I subtract those two numbers, I get 350. That's the actual answer that you want. Lastly, volume can be milliliters or it can be liters. Since this question here gave us milliliters, that's what we will put on our answer. Okay, let's do some of these neutralizations. So neutralization is always an acid and a base. So here is the acid, and this one is the base. We know that we always have to make water, and we have to make salt. That's the general formula for any neutralization reaction. Okay, so now we have to write the formulas for everything, and everything here is ionic. Okay, so water we know is HOH or H2O, doesn't matter how you write it. Hydrochloric acid, acid has to have an H at the beginning. Hydrochloric means it's combined with chlorine. Then you need to crisscross. So H has a +1 charge, Cl has a -1 charge. The formula for hydrochloric acid is HCl. Okay. We'll do the same thing for our base. Ammonium is NH4 + 1. That's no hugs for Juan. Hydroxide is OH -1. Crisscross, the formula for that is NH4OH. So then we know that we're going to make water, which is HOH or H2O. And the way that you're going to figure out the salt is you're going to look at the leftovers. So the H from the acid went there in the water, and the OH became that. So the leftover pieces that we have for the salt that haven't been used are the NH4 and the Cl. That's what we're going to crisscross to turn into our salt. So NH4 goes first because it has a positive charge. Cl is second because it's a minus charge. When I crisscross that, I get NH4Cl. Lastly, you need to be able to name that salt. Because it's ionic, you will not use prefixes. So this is just called ammonium chloride. Okay. Alright, if you need a little bit of help with the last one. Oops, let's get it on your screen. This is neutralization, so we always have an acid plus a base. You will always make water and salt. Okay, so we need to write the formulas for all of these pieces. Acid always has to have an H in it. Sulfuric, because there is no hydro, I know that it is the polyatomic ion SO4. If it said hydro in front, it would be hydrogen plus sulfur from the periodic table. That's not what we have, so we're going to ignore that. We need the charges for these to crisscross. This is a +1, this is a -2. Crisscross applesauce. The formula for this is H2SO4. Plus, now we need to do the same thing for the base. Potassium is K, hydroxide is OH, but we have to crisscross. Formula for that base is KOH. Okay. Now, water we know has to be H2O, same thing as HOH. I like to write it like that because that helps me to figure out the salt. Okay. Thinking about the water and where it came from, this H from the acid became that part of the water, and the OH became that part. The leftovers are what we're going to use to make the salt. So we didn't use the SO4 and we didn't use the K. That's what we're going to combine. So I'm going to put the K first because it's positive, right? Has a +1 charge. The SO4 is a -2. We will crisscross that. The salt's formula is K2SO4 when we crisscross. Lastly, you have to name it. That is ionic because it's a metal and a polyatomic ion, so you will not use prefixes. This is called potassium. SO4 is called sulfate, and remember, those are things you do not change their names. Alright, if you have any questions, come on over and ask.